And welcome to the moles and particles video. So this video is going to walk you through how to do calculations specifically with moles and particles. So before we get started, I want you to pause the video and I want you to write down what you see, whether it be in your notebook or if you want to just take notes on a piece of paper. But everything we do is going to refer back to these exact steps right here, 1, 2, 3, ABC. And we're going to use this for this entire unit as well as the stoichiometry unit. So it's really important to get these steps down and to reference them if ever you feel stuck. So hopefully you paused the video, you wrote all those down, and now we're ready to get started. So anytime we're looking at a problem, the biggest issue that students have is knowing what the heck to do. Like, we're looking at a bunch of words here and numbers, and it looks confusing. And so the first two steps that were given here, they really break the question down. They're your prep. And in order to actually answer the question, which is A, B, and C, we need to do the prep work first. So I'm going to be looking for what the question wants, and that means I'm looking for units and a substance. And I'm going to highlight that in red, but I'm going to make it a lighter red highlighter. Boom. Okay. So coming over here, I want to know what the question wants. I'm going to be looking for keywords like how many, how much, what are, and here we have how many moles of sulfur. So there's my units and my substance. Then step 2, if you look at your notes, it says that you need to identify what's given, and that's always going to be in the format of a number, units, and a substance. And here, that's pretty easy to find in this simply worded question. I have a number, 2.86 times 10 to the 21st. I have units, that's my atoms, and then substance is sulfur. There we go. So I picked out my important pieces of information. I did steps 1 and 2. And, honestly, when we get to the more complicated questions, this is going to be half the battle. Now we just have to plug everything in and draw our chart. And really, it just all falls together beautifully, and the work is done for us once we get to this point. So A, start with what's given and draw the chart. That means that I start with what's given in terms of what I highlighted in green. Green means go, so I use that color for a reason, but you're always going to start with what's given, the number, units, and substance. So I'm going to write that down, 2.86 times 10 to the 21st, right? Yep. Atoms of sulfur, and I don't want to write the word out, probably just because I'm lazy, but I'm just going to put the S because that's the symbol for sulfur. And then, like it says, I'm going to draw my chart. And my chart just means a line underneath and then a line down, separating this from the next step. Now, this chart here that we call it, it's really just a big fraction, and we look at the vertical lines, these up and down lines, as parentheses. So it's kind of like we're multiplying everything on the top and then dividing by everything multiplied on the bottom. But that makes it sound difficult, so just know that it's kind of like a big fraction. All right, so step number B, Step B says plug in equalities. Now, where we're at here with moles and particles, your equality is either going to be revolved around the mole in 6.02 times 10 to the 23rd or the atoms per molecule, in which case you have to count. So I'm just going to go over here real quick. Oh, it's not in this one. Hang on. I'm going to go here, and I have somewhere. There it is. So basically, when we're talking about atoms of an element like sulfur in our question, or how many molecules, we just have this equality, the 1 mole for every 6.02 times 10 to the 23rd atoms or molecules. So this and this is the exact same thing, this red and blue track. The difference comes when we're talking about atoms of a compound. So basically, if I have 1 molecule, how many atoms is it? Like, for example, water has 3 atoms in every 1 molecule. And to find it, you just count. Like, you literally look at the formula and count what it wants. So here, again, water is 3 atoms because there's 2 hydrogen atoms and 1 oxygen atom. So you're just counting. And that's the second thing that we need to keep in mind when we're drawing our charts. So let's go back to our problem here. Okay. So before I do anything, I know that atoms of sulfur have to be on the bottom there. And the question should be why? Well, if I take atoms and I divide it by atoms, what happens? Hopefully you say they cancel out. And that's true, and that's exactly what I want to happen. And that's why it says over here, when we plug in our equalities, it's always what we want over what we started with. So in this question, what we want in red is moles of sulfur. Moles of sulfur. So if I add moles to this, atoms times moles divided by atoms, again, the atoms cancel out and I'm left with moles, which is what I want. So units wise, the chart really helps you see why we're doing the math that we're doing, why we're doing the calculations that we're doing. Okay, so now it's a matter of what numbers go in here. So for mole, it's always going to be the number 1 for now. So mole is always going to have the 1 next to it. That means we need to have a number down here. So what do we do? How many atoms are in a mole? Well, how many atoms would be in a dozen? Hopefully you're saying 12. So how many anything is in a mole? The answer is 6.02 times 10 to the 23rd atoms. And it's really important that you guys remember that if we're counting things like atoms or molecules or particles, that it's always 1 mole and then it's always 6.02 times 10 to the 23rd. And then we plug that in our calculator and we get an answer. And if you guys aren't sure how to plug that into your calculator, make sure you watch the calculator video. But you're basically just going to use that E button, 2.86 E21 divided by 6.02 E23, and you'll get a decimal number. I'm just going to real quick go back to, nope, not that one. Where do I want to go? Here's where I want to go. I'm just going to go back to this table here. Again, you can pause the video if you want and copy this down, but this is kind of like a roadmap. We can take the mole train, we call it the mole train, and we can go to and from atoms of an element, to and from atoms of a molecule, as well as to and from atoms of a compound. And the way that I drew this, I basically did the work for you. So in the last question, we were given atoms of an element, right? And we were trying to get to moles. So if we're following that pathway in that direction, then we should have plugged in 1 mole over, wait, am I saying the right thing? Hang on. I can't remember the question. Yeah. I was saying the right thing. Okay, so we should have plugged in 1 mole over 6.02 times 10 to the 23rd atoms, because that's what's, written right here. And if you look at our work, which I totally spaced there, that's exactly what we did, 1 mole over that many atoms. So there's lots of different ways you can go about this. The easiest way, and the way that I recommend, is just focusing on those units canceling out, and ending with what you want on top. So make sure that what's here matches what's there, and you should be good to go. There will be another video where we talk about how to do where it's, atoms of a compound instead of atoms of an element. So if you're looking for the more complex stuff, go ahead and check out that video, and thank you very much.